So let's start with the next presentation regarding the rare earth-based permanent magnet and what Orano is trying to do in this area of activity. So just to introduce myself, I'm Benoît Richebé. I took over this position to develop Orano's activities in this field about a year ago, and before I worked for a long time in the strategy field. So first, what are we talking about? What you need to know in order to go through this presentation, you need to understand what is a rare earth element, and you need to understand what is a rare earth-based permanent magnet. So a rare earth element, those are 15 to 17, depending on the definition, element of the Mendeleev table, at the bottom part of the Mendeleev table. And they are used in numerous sectors that are represented here, from the optics to the thermic catalysis, up to the smartphone and the earphone, etc., your screens. What the areas, the sectors we are looking at are the wind turbines, the EV and hybrid vehicles, and obviously the magnet that are generally used in these sectors. So in short, the rare earth elements are really the vitamins of the modern era. So first thing you need to know, this is a rare earth element. And the second pertains to the one use case, a permanent magnet. So you have different types of magnets that are represented here. The one we are looking at is the red one, the neodymium iron boron permanent magnet. And you can see in short that these magnets are the most powerful that you can find in the industry, despite the fact that they cannot operate at a very high temperature. But you use these permanent magnets typically in the electric vehicles and the wind turbines for the electric machines. Just to give an order of magnitude of what weight, what volume are we talking about, in an hybrid vehicle you are using 300 grams of permanent magnets, not for the traction motor itself, but rather for the small actuators like the braking, the steering, the hatch, le haillon en français. When you look at the normal battery electrical vehicles, you can use up to 2 kilograms of permanent magnet. And when you look at wind turbines, some designs of them, and not all of them, but some of the design can use up to 2 to 3 tons of magnet. So these are big numbers. And this is really what we are looking at. Then you need to understand how we structure the value chain of the rare earth and permanent magnet. You need to really look at it from an integrated, a global perspective. So you generally mine the rare earth element first, and most of the mining activities are taking place in China today, and I will come back to this later. Then you need to separate the light rare earths and the heavy rare earths, and we sometimes forget the heavy rare earths in our strategical approach. So you have a separation based on solvent extraction, hydrometallurgical type of processes. Then you need to reduce this oxide into a pure metal, and then you are able to manufacture a permanent magnet and use it in typically for Valeo, for instance, Bosch, or whoever will use this type of permanent magnets in the traction chain of the electrical vehicles. But then there is another thing that you need to take into account. You need to take into account that your permanent magnets will have an end of life, because typically they will be oxidized, and you can do recycling. You can recycle these permanent magnets either with a sort of a short loop recycling, which is not mature yet, but we are working on that. And I will come back to this later, or a long loop recycling, where you typically dissolve the used permanent magnet via an hydrometallurgical process. And in this area, in this value chain, Orano is focusing really on the key strategic segment, rare earth separation, metallization, and the magnet manufacturing. Just to give you an idea also what are the trends, so I already mentioned the fact that you use as permanent magnet in the traction chain of the electrical vehicles. I think I don't need to convince you that you really need to, the industry need to really shift into the electrical vehicles technologies. So I'm not coming back to this. But then the main question, and this is what we are working on, you need to manufacture permanent magnet, but on a virtuous way, meaning that for an ISO performance, trying to use less rare earth element. On the left part of this, you can find some figures really illustrating the fact that we need to really work on on developing these technologies. When you look at the battery electrical vehicles, you have here in blue the growth that is expected in kiloton of neodymium magnets, and you can see actually that this is really huge. And this growth, on top of that, you also have the installation of the windmills, particularly the offshore windmills. So this is really the area we are focusing on. But and this is where we have the problem. The rare earth element and the permanent magnet value chain, it's on a highly volatile market, and we have a strong dependency to China. So if there is one thing that you need to have in mind, 30%, 60%, 90%. 30%, this is the ore reserves of rare earth element of China. 60%, this is the volume of ore extraction they are doing, and 90% is the global domination of China on the whole value chain. So when you look at the energetical transition, you need electrical machines, you need permanent magnet, and you need rare earth element. But to do so, you will be increasing, and if we don't do anything, you will be increasing your dependency to China. And that's the reason why a lot of Western countries have engaged into innovation projects in order to reduce this strategic dependency to China. And this is what Orano is trying to do with the Magnolia project that we have launched last year in a consortium, with Orano leading the consortium, the CEA from Grenoble, CEA Litten, who is working on industrialization of recycling and manufacturing processes. We are also working with two dismantling and collecting companies, Demantel and Paprec. Demantel is a small startup from the east of France. And we are also, we teamed up with Valeo, and Valeo, I don't need to explain you, but obviously this is important for them to make sure that the recycled permanent magnet can fit into the motors. Otherwise, you haven't demonstrated anything. And what we are trying to do is to make sure that we really develop innovative processes for recycling and manufacturing the high performance magnets that will be needed for the battery electrical vehicles. So the end game for Orano by the end of the 2020s is to become a manufacturer of high performance magnet, relying really on competencies that I will describe on the next slide. And we basically are here. We are still in the R&D stage, and we will be starting by mid 2024 the process pilot in Grenoble. Then we will develop an industrialization pilot by 2026, and then we will launch the real manufacturing plant. For this, why have we engaged into this diversification? It's because we actually have quite numerous technical know-hows that are valuable into the manufacturing of permanent magnet. that I've listed on the left part of the slide. And especially, we are actually quite good expert in the metal chemistry, hydrometallurgical or pyrometallurgical processes that are actually needed in this value chain, and especially in the magnet manufacturing, sintering as well, fritage en français. You also need quite a good experience in confined spaces, confined atmosphere, because the powder, the magnet powder that you will generate during the process is extremely heavy of oxygen. So you need to work in really an inert atmosphere, and this is something that we master a bit. Mining, obviously, Orano group is a top 3 leader in uranium extraction. And actually, when you extract uranium, you find rare earth element. And when you extract rare earth element, you have uranium and thorium. So we know this value chain, we know the miners, and we know the people who work with them. And that gives us a bit of legitimacy to enter in this value chain. Once we will have the real industrial magnet manufacturing plant in France, it's not an easy piece of cake. This is really a pyropheric activity, but we do manage in France large and extremely complex industrial sites. So that gives us also some technical know-how. But on the other hand, we don't know everything. We are, shall I say, humble in this innovation activity, and we are missing some skills. And if some people are interested, you can raise your hand. What we are missing is competencies in magnetism, because we don't do that in Orano. And obviously, a magnet quite rely on magnetism. We know how to manufacture them easily, shall I say, but we need more expertise in magnetism. Still in metallurgy, I did say that we have good expertise in metal chemistry, but still we are interested in having other competencies in this field, material behavior. We are also looking at some building blocks, really pieces of the puzzle that we need in order to be able to produce a high-performance magnet by the end of the 2020s, looking at automatization, robotization. We really believe this is key in order to be competitive enough compared to the Chinese manufacturer. Numerical modeling, industrialization, additive fabrication. I didn't mention that, but we are trying to not only to manufacture magnet, but really to be at the edge of the innovation in this area. And in the permanent magnet field, normally they are manufactured in square blocks, and then you cut them in order to have the shapes you desire for your rotor. But now the motor manufacturers are requesting complex shapes in order to optimize the rare earth element content, and you need to manufacture them. And what we are trying to do with the CEA Grenoble is to develop a powder injection molding process in order to directly have the requested shape and avoid losing 20 to 30% of the materials. Traceability as well. This is not something that is requested yet by the European Commission, but we foresee that the manufacturers and at the end of the day the consumers will be willing to know where this rare earth element will be coming from. Obviously, this is not a big news for you, but the rare earth element value chain is actually not extremely virtuous from an environmental standpoint. The extraction of the ore in Inner Mongolia, in China, or even the heavy rare earths in Thailand or Birman is actually quite how should I say, it's not clean. It's not really clean because it's using a lot of chemical agent. And we are also looking for specific knowledge, specific competencies from the automotive sectors, like motor designer, because obviously you understand that you are not selling only a permanent magnet. It has to fit into a water, and the optimization of the permanent magnet must be done consistently with the motor optimization. And this is something. This is typically a competency that we will have to staff in the project in order to be how can I say, really at the edge of the innovation in order to answer the customer needs. Purchasing, sale in the automotive sector, marketing, life cycle analysis. I already mentioned this with the traceability. So in short, this is what we are trying to do, exploring this whole value chain. We have other projects that we are trying to launch, but those are not public yet. And at the end of the day, what we want to do is to increase the sustainability of the permanent magnet and increase the sovereign economy of the European Union. Thank you very much.